tell me when to go. Here, let me.
There.
You got it?
Yeah,
You
yeah.
got it there? Okay, good.
Yeah. So for
Okay.
those that don't know, my name is Andrew Johnson. I'm an automotive engineer by trade. As you can tell kind of from some of the things that I've built here. I was first licensed when I was in college as KC9 MWX down in Indiana. I got my general a year after that, and then my extra a few years back. And my favorite part of the hobby is building things. So antennas, circuit boards, and of course 3D printing. And you can see here me at my highest and my lowest. I put that in there just to make that joke. So that's Pikes Peak, and the one below that's Badwater Basin, which is the 282 feet below sea level. So yeah, what is 3D printing? So for those of you that are familiar with normal machining operations, that's kind of called a subtractive process. So 3D printing is an additive process, and it's a process of you take a three-dimensional CAD model and you basically assemble the material in that form. So one of the things that helps with, in addition to be able to do it at home on your desktop, you can see with this picture, if you want to build say something the size of this laptop, you have to take the a brick of material that big, and then most of it goes to waste, in chips and all that. Whereas with 3D printing, you only use, the material for the part plus whatever you need to kind of support it, and whatever overflow you have. So it's a lot more efficient use of material. You can kind of make some designs that you ordinarily couldn't. For example, that 3D object picture, the cube with the holes in it. Um, Very hard to make like on a mill or a drill press or something like that. With the 3D printer, it can just pop it out. So if you have, a huge complex shape, might take you, machining time in the, hundreds of dollars to make. With the 3D printer, if you make it out of plastic, you can kind of churn it out for like, 5 cents in plastic. So, and then the way that it works is it takes each kind of cross section of the object and stacks it on top of each other. So if you had a normal printer, right, just your normal desktop inkjet, and you print it out, 5,000 pages each with a different shape, and you cut those shapes out and you stack them, you'd have a 3D printed thing of paper. So it's that same basic concept, just different methodologies. So what does this have to do with ham radio, right? It's ham radio club, not a 3D printing club. DIY has always been a huge part of ham radio. I'm sure some of you probably had Heath kits back in the day, building those, building your own wire antenna. So it's something that we as hams kind of have a lot of experience with, trying to make our own gear, make our own equipment, and break it, make it better, and all that fun stuff. So with the advent of cheap 3D printers, you could take that to the next level. Instead of being limited to what you can get at the hardware store, you can fire up your computer, make whatever design you want, hit print, and then, a day later you have your part, which is pretty cool. So you can kind of see here, it could be as simple as, a project box to hold a balun, or isolators for the end of your antenna, or it could be very complex, like some of the projects I'll show you later on. So 3D printing processes, we'll kind of start with the first one that kind of came out in the 80s. This is selective laser sintering. So what this is you have a bed of material, either metal or like a polymer of some sort, and you selectively melt it at certain points, and then you lower the tray, and then as that tray lowers, you put more powder on top of it, melt that powder, and then you do that until you have your final project. This is kind of what's used in like industry when you see the 3D printed metal. It's usually selective laser sintering. So these would be really nice. If anyone has one, let me know. Be kind of cool to use one of those. What came out of this a couple of years later in the mid 80s is the stereolithography. And it's the same basic principle, except instead of a polymer or a metal, you're actually using a UV resin. So when you hit it with the UV light, it cures and turns solid, but only where the laser hit it, or the UV laser hit it. So that way you can do the same thing where you trace your one layer, lower it, trace your one layer, lower it, and you just keep doing that until you build up your final object. So you can see here, you get about what is that, 0.05 millimeters. So 2 thou to 6 thou inches. So these are really good if you're making like models, miniature figures. These have really good resolution for that. The last one, kind of the last one to the scene, but the one that kind of I think 90% of people use is fused deposition molding. And this is where you take a molten object and you trace the cross section of it and you kind of build up from there. I know Joe mentioned 3D printed houses. This is basically how that's done, except instead of a table, you move like a concrete pourer. So the concrete pourer kind of traces out the wall, and you just kind of keep doing that, building up and up and up until the house is done. So it's pretty cool to watch because you could like, instead of taking like, weeks to build a house, they do it in like 2 days because it could run overnight. You just have to have someone watching it, make sure it doesn't run out of concrete. So home 3D printing, like I mentioned, the SLA and FDM are kind of the two main things that you'll see. The SLA I haven't used too much. It's a little bit messy because you have to pour the resin in and then take it out. But it is really good, like I mentioned, for miniatures and artistic stuff. The fused deposition molding is cheaper. It's cheaper to run. The print quality is not as great, but if you're like me and you focus mainly on functional parts, it's kind of not that big of a deal. I just want to make sure it doesn't break. I don't really care what it looks like. So, entry level printers right now on Amazon, they're not the best, but they'll kind of get you into the hobby if you wanted to try it out, are about $200 on Amazon right now. In the 1980s, that would have been $650,000 in today's dollars. So, what a bargain comparatively. So, and once you have the printer, if you want to upgrade anything, you could 3D print your own upgrades. A lot of people put stuff online. You can print it. You could probably, if you want to get one of these and, you could convince someone that you're actually saving money because anything that you have that you break, you can actually repair it yourself, print a repair piece instead of throwing the object out. I've done it for, one of my dash cam mounts and some other stuff where the plastic breaks, I kind of glue it back together, measure it, and then actually 3D print my own replacement part. So actually save money. Because that's what I tell myself. So you can see here, you might think, okay, it's plastic. Okay, is that going to last, or what's the deal with that? So here's kind of some examples of the main materials you'd use for 3D printing. I highlighted the two in the middle, PLA and PETG, because those are the most common ones. I think everyone kind of starts off with PLA. PETG has a lot more benefits. It is a little bit harder to print and more expensive, but not to the point of something like ABS or polycarbonate, which are really good. But for ABS, you need like a custom enclosure to kind of keep the environment warm. Polycarbonate, like you got to get it really hot. Sometimes you'll have to have special nozzles because of carbon fiber. If you wanted to print carbon fiber, it'll abrade your nozzle very quickly. So you have to have a hardened nozzle. So like I mentioned, PLA and PETG will kind of do 90% of, probably even 95% of what you could ever need. And wherever they're kind of weak, you just design around it. Me personally, I do everything in PETG now because I have my printer dialed in. And you can see it's good to do a little bit hotter temperature, and it's a little bit more durable. And it has some pretty good UV resistance too if it's for something that's outside. So now that you kind of got the basics of what is 3D printing, we'll kind of go through the process of from design to it actually being printed, which is pretty straightforward. So to have something to 3D print, you could either download it through the internet. My favorite site is Thingiverse for that. A lot of people, I just searched ham radio and pasted a screenshot. So you can see all of the those green keys and anything that you could think of. You could just search there to see, did someone else already make this? And if they did, you could just download it. Takes like 2 seconds and then go from there. If you're a little bit more handy or more involved, you can get like a CAD program or a modeling program and actually design it yourself, which is what I did for my rotator that I'll show you in some of my other projects. There's kind of two different types of modeling program. One of them is like more artistic, It's a little bit better if you're actually modeling like characters. I don't have too much experience with that with my background in engineering, but I do like FreeCAD. As the name says, it's free and open source, so it's doesn't cost anything. Some of the stuff like SolidWorks and all that, if you can't get a free license, I know get pretty expensive. So I think what is it? Autodesk is another one, and there's a few other programs that actually have free stuff, but it's a little bit limited in what it can do compared to some of the full-on CAD tools. So once you have your design, either that you downloaded or you made, you have to put it into this program called a slicer. And what it does is, as I mentioned before, how it's basically the 3D print is just a stack of 2D images. The slicer slices the 3D object into those images and then creates the toolpath. For those of you that might be machinists, it produces G code, and then it could send that to the printer. So the printer will take those instructions and say, okay, I'm going to move to here while extruding, this much material. Then I'm going to move to here and then go up a level and then kind of repeat that thousands of times until you have your object. So here, hopefully this will play. Once you send it to the printer, it'll print. And this is a time-lapse video of a spacer that I made. So you can kind of see the head just kind of moves and goes up, and you kind of see the parts slowly appear. It's really cool to watch these for longer parts, but all of my videos for the longer parts, like I ran out of storage for, so like they quit halfway through. But there's some programs you can get, like this is Octoprint. So I have a Raspberry Pi that runs my printer, and then I could hook a camera up to it and have it video, remote manage it, and all that fun stuff. So I could, turn the print on, go in another room, not have to worry about it, check it from my phone, all that fun stuff.
What is the advantage of the head and the table both moving? Just in that video, I saw that head and the table moving.
Yep. So on this, the x-axis is the head, which will go this way, and the y-axis is the table.
Thank you.
Yeah. So the head does X and Z, and then the table does Y.
I thought the head did Y as well.
Yeah. Yeah, there's a couple different formats. Some of them, the table will move in X, Y, and the head still. Some of them, you'll have a full-on gantry where the head does X, Y, and Z. And then there's even some that have the, I don't remember what it's called, but you have like the 3 legs basically. And like that can do all of the crazy axis stuff. So some tips and tricks. Sorry for the people online. I guess I'll try to share some of this stuff. So here's an example of a 6-meter folded dipole antenna. So show it to the people online. So you might think, hey, I want to build an antenna like this. Well, you don't have to 3D print the whole thing. If you go to the hardware store and say, hey, these fiberglass parking markers are pretty neat, I bet I could use these to support an antenna. You could say, okay, I'm going to use these as my main structure, and then I'll just 3D print kind of all of the fittings to get the wire on there. So, don't worry about trying to 3D print everything if there's other objects that'll work better for your application. So in this case, it's zip ties and wire and these parking things from a hardware store with some hardware. And then I 3D printed the centerpiece and these end pieces and then threw it together. And with this antenna on FT8, when we had some 6-meter openings, I was able to get down into, I think Mexico was my furthest contact. So I was able to hear a little bit farther, but they couldn't hear me. But yes, so this is probably, I don't know, $5 worth of stuff, maybe.
For 2 meters.
6 meters. So yeah, it's 6 meters long, but it's folded and to save space. So yeah, 6 meters in the space it takes for 2 meters. Pretty nice. So you can see here's on the screen is a Yagi I did with a similar principle. I used the fiberglass for the main shaft and then some brass rod for the elements. And yeah, it's you could buy an arrow and for like 150.
Said, I've never seen her mad before, but I think she was pretty mad about that.
Yeah. Can you go on mute? Yeah. Oh, is there like a mute all button? Oh, there you go. Okay. So some other things that you could do. if you had something you were trying to drill in steel or wood, or even like on a wall, you could actually 3D print a drill template. For those of you that have built project boxes with the bulkhead mount coax PL259s, it's really useful for that. So if you say, hey, I want to drill the pattern, you 3D print the pattern, kind of align it to where you want it, and then you could just drill, and then you have a perfectly drilled hole that you could then put the connector onto, and it looks good. And you're not like, oh, I drilled that too far over, or too far under, or whatever. So very useful for that too, not just 3D printing projects, but tooling to make projects with other stuff. And then lastly, if you can make really big parts out of tiny parts. So the example I have here is my rotator. And if you use these 3D, these inserts for 3D prints, you put them on the tip of your soldering iron to get them hot, and you press them into holes. And you could actually take stuff apart. They hold very well. And you just, screw it in. You don't have to worry about stripping plastic threads. And it holds stuff together very well. So you might, like as I mentioned before, a lot of people think plastic, hey, it might be weak. If you choose the right material, the right print orientation, and you design it correctly, it could actually be pretty strong. So I have my examples here on my Jeep roof rack. I 3D printed antenna mounts. And then I just have the coax tied in with copper braid to the roof to ground it. And I've actually forgot my antennas on my roof one time and drove in, and it broke the PL259 before like the plastic was fine. So yeah, the plastic, I was like, oh, it's probably got to print a new one, but nope, I looked and it was fine. The one caveat to this is it does sometimes can get brittle with UV radiation. So if you do park it outside a lot and not in the garage, you probably want to check it every couple of months just to make sure there's not any cracks. But I think I've had these on for like almost 3 years now, and they look almost as good as the day I put them on. And go down the highway with a VHF antenna and an HF antenna, and it holds it pretty well. So
It's all Petri.
yeah. So and then the kind of the ultimate thing, right, is if you kind of combine 3D printing with electronics, Arduino, and some other stuff, you get mechatronics. So I do have this rotator over here. Unfortunately for the, actually I could probably rotate this, can't I? The camera, right? So I actually have a Bluetooth dongle on there. Let's see if this will work. So you can see it goes up. Oops. And then wait till oop. Oop.
You can see the rotating.
Yeah. So it's pretty neat because I lost connection. So you could actually hook it up with a satellite tracking program, and the Bluetooth will send it commands, and then as the satellite, crosses the sky, it'll just kind of follow it. Yeah.
Nice. Yeah.
So not to brag or anything, but I did that almost everything. Like I'd say 85% of that of the 3D print stuff I designed, and then I did the PCB and software too. So that was like one of my COVID projects when I was really bored. So a lot of time there, but it was pretty fun. The other one that I have, which is pretty nifty, and this actually probably would cost thousands of dollars if you wanted to get one from, I don't even know if you can get one from DX Engineering, but a variable inductor. A lot of times you can get them for, very low current kind of trimming on a PCB. But if you wanted to say have a vertical antenna that you'd be able to tune from somewhere else, you could, build a 85 microhenry coil, hook it up to 8-foot whip, and then you could, in theory, tune it 80 to 10. I haven't done that yet. The SWR plots do look promising, but just a motor with the screw through here, and as the screw turns, it moves the wipers up and down to effectively shorten or lengthen the coil. So stuff like that where, you know, hey, I want a variable inductor, but I don't want to pay whatever, you know, thousands of dollars it's probably going to cost. You can just kind of build it. Obviously, it's not going to be as accurate or as good, but if it breaks, you just print some more parts, wind it back up again, and away it goes. So
Where it is, screwdriver and
yeah, that's right. It's actually I kind of based it off the Yaesu's ATAS 120. So it's the same basic principle, but instead of spending $300 on theirs, I was like, I'm going to spend 300 hours build my own. So, you know, if anything that I said tonight kind of piques your interest, if you want to get started, a lot of libraries like here offer 3D printers. There might be some limitations on what you could print. Usually they don't want someone taking something that's going to, you know, take 8 hours or run overnight or anything like that. I did kind of paste some other local libraries that I found. Commerce Township, Orion Township, Rochester Hills, and Madison Heights. Madison Heights I saw also has a 3D scanner. So if you don't want to model something, you could just take it in, throw it on the 3D scanner and actually get a 3D model of it and then print it from there, which I haven't used one of those yet, but that actually sounds kind of cool too.
Yeah, that's where's it going?
Madison Heights. Yeah.
Actually has a separate room for all of this.
Oh, nice.
So it's not for the library, it's a separate room specifically for that.
Oh, where's,
At the photo
is it in the library or next to the
It's
library?
in the
room.
library,
Library,
Okay,
and it's
Cool.
under the library, not admin.
that's good to know.
our staff that knows what they're doing.
Yep.
Are you aware of any printers available for general public use that would be able to create aluminum brackets? Specifically, I have for my more fine junk antenna needs a replacement bracket, and since that company no longer exists, I need to either 3D print one or find a fabricator that can make them. Are you aware of anyone that can print aluminum brackets?
Yeah, I do know there is like, that is technologically feasible. The cost would probably be pretty high because most of those are owned by like R&D. I don't think there's anything like consumer or even like pro hobbyist grade that would do that. Having said that though, one of the things that is possible with 3D printing is you could actually print the bracket as you'd want it and make a sand mold out of it and then cast aluminum your own bracket. A lot of people do stuff like that for other projects where they'll do a 3D print of the shape that they want and use that to make a casting mold and then cast it out of metal. So that is another option. I haven't done that. It sounds like a good way to start a fire. So
Taking small pieces of aluminum or copper, and the best way in what you just said, that you 3D print what you want, and you just sand packed into the mold. And you can see that done on many YouTube pages as well. But you gotta be very, very careful of that hot metal because it will singe you.
yeah, and then it'll probably stick too because it's liquid. So just for some show and tell, I know I've had some other members that have no 3D printed stuff. So we have some radio as well as non-radio stuff. So we'll open the floor up. Again, if anyone has any questions, feel free to ask. Like I said, it's a really great hobby because you could actually use it like in almost every other hobby. So like almost anything you could think of, like, oh, if I had a 3D printer, like I could do this instead of, you know, buying whatever. So
Let's go to his house.
I have a question.
yeah.
So if you use a program like SketchUp or something, a
Mhm.
3D drawing program, what's the file format that goes from the drawing program into the 3D printer program?
It's still.
Yeah, STL. Yeah. So the slicer program that I mentioned,
Got it. Okay.
that'll take numerous different 3D formats.
Yeah.
I'm not sure all of what's supported, but it'll take like everything that is supported. And then you put that into an STL, and then that slices the STL and then spits out the G code. Yeah.
Yeah, you can also use G code with it too. So if you have anything that you know, like the CNC or CMM codes that you have it can actually be transverse into STL.
Yeah.
So I brought a couple things. I tried to keep it as radio as I could. Start with, this is somebody else's design that found online, and I think somebody brought this to a breakfast, one of our breakfasts on Saturday morning once. Also, it's got the surface mount PL259 in here. It's it's reverse threaded for a balance. Nice little thing, prints up really pretty quick, and it's got places to hang it with. Those who are at field day may have seen this. I found a keyer online here that somebody else designed and printed it out as I was going to start. I still haven't, but I'm gonna start Morse code. And so I printed it out and put it together and went, oh, that's pretty loose and flimsy. I can make that better. And that's usually what happens.
Yep.
I'll find something and I'll go, oh, that can be so much better. And I'll spend another 15 hours making it great. I think this is version 4. Yeah. Marv used this at field day a little bit to test it out for me. He said it sucked.
No, I said it was just a little light.
Yeah, it's like, this is filled with lead shot. I'm the kind of guy that goes, what do I have? I don't want to buy. What do I have? I did something for somebody a long time ago made out of wood, and it needed weight. I don't remember what it was. It might have been, a car for what's those?
Oh, Pinewood Derby.
Pinewood, might have been for Pinewood Derby. I don't know what it was for, but whatever it was suggested I use lead shot. Well, I could only get a 50-pound bag of lead shot, and I used a tablespoon of it. So I have lead shot. So when I redesigned this, Marv said it's light. Well, I thought it was pretty heavy till I picked up Marv's and went, holy cow. Okay, I get it. So his other comment was, this is too hot. So I thought at first I would just, make tabs on these. Now it's down here. But what I'm going to do is I'm just going to make the base bigger. Now your hand's sitting on the base and it'll have a lot more weight, and we'll have you test it again. I like making antennas, and I like having, screwing around with antennas. The first antenna that I made was a quarter wave ground plane made out of coat hanger. And I'm at 10 and Ryan, and I was reaching 15 and Shaner, whatever that repeater is there, the firehouse there. I was reaching our repeater. It sat in my shack on a PVC pipe, touching the ceiling. It was, so it's 7 feet in the air, 6.5 feet in the air, and it's reaching that far. I love the quarter wave ground plane, but then I learned about radials. And so doing POTA, I've learned more radials are better. And of course, I know I get it. You get to a certain point and more radials, it's just more work. You're not getting as much bang for the buck. So, but I just recently started thinking about the quarter wave ground plane again and thought, well, it's got 4 radials on it. What if it had 8? So created this, the PL259 will, the surface mount will fit in there. The radials will come out of here. This will protect it. So the other problem with the quarter wave ground plane is it's very, it's easy to damage. And so what I'm going to be doing with this is I'm going to be using, what are they called? Nylon tubing. And I'm going to use, the wire's just going to run in that tubing. Birds can land on it. You won't bend it up anymore. And then this will just keep the water off. You know, the nylon tube that's coming out of here will be sealed here and sealed on the top, so no water will get in. That just having fun, making stuff like that. And then, few more quick things. While I'm doing POTA, last time I did POTA, I'm sitting there with my headphones on because it's sometimes hard to hear. You know, the speakers, you know, facing towards the sky, and it's just sometimes hard to hear. So I'm got my headphones on and someone came up behind me, scared the crap out of me. You know, I don't know how long they were standing there until they put a hand on my shoulder. Oh, I had scared the heck. So I made this. This just sits on top of the radio. Now the sound comes out of the speaker and it's coming right at me. And this works great. It just, you know, took me, I don't know, 30 minutes to print this and another 30 minutes to design it. And then finally, this isn't really ham radio, but a friend of mine sent this to me and said, you might want to print this. This is cool. It prints in two parts. The silver is one part, the black are little like springs that just fit in. And all this is, and when you're soldering, you stick a wire in there, you stick a wire in there, and it holds them in place for you. And it's really quick, no turning. You know, you have a little vice that I normally use. You gotta, you know, it's one clamp, and you're trying to get both wires held in there while you're using it. I need 4 hands to do that. This super easy, super quick, and there's a million things like this. You search, if you just did a Google search on cool tools, STL files, 3 letters, STL, cool STL tools. There's some really wicked cool stuff out there that's really simple, really useful, and fun for people like me who go, I can make that better.
How are we doing on time?
About 10 to, I guess.
Okay, so then we have some other stuff, if you want to see some, not necessarily radio, but some other tools. That arch reactor, I think, is probably the best.
Some of it's radio related, but most of that stuff's
Yeah.
on poles or.
Yeah.
If anyone's familiar with Meshtastic, do a few different nodes here with,
Yeah, I was gonna say, that, you could do a lot of cool stuff with the Meshtastic.
Yeah.
Like there's a lot of stuff online for that.
these like,
Yeah.
just like you said with Thingiverse, you download the parts. This is made out of 3 pieces, the gray, the black, the gray, all the electronics bolts in the middle. Of course, I didn't 3D print the antenna or the electronics. I used another smaller one, and this is the battery and everything encased in there. If anyone's not familiar with Meshtastic, you can actually Bluetooth your phone to this and then send texts over radio waves. So this is the one, all the electronics are in this little box this is a solar light from Home Depot, and then I just 3D printed, pulled the light off, 3D printed this piece to go on there. It's on a piece of PVC, put it about 20 feet in the air, and I can reach with, actually the smaller one, this antenna works better than the bigger antenna. I can do about close to 2 miles in text between the two. So it's kind of nice if you put one in your car, give one to the wife, whatever. If you know we ever have a grid down situation, you can still text your family and get a hold of people. And the nice thing about them is they mesh together. So if I have one, and then let's say Andrew had one, and he was close enough, my wife was on the other side, it would piggyback off his and go to hers. So you could, if enough people had these, we pretty much have a free open system for texting over the air.
That's a hit, by the way.
Yeah.
Yeah. A lot of people have them, but they don't keep them active.
Yeah, the
The
other
nodes
thing
go up and down.
too that's kind of cool is you don't need a license for that.
Yeah.
It
there's
uses
no, like,
the ISM, the 900 megahertz ISM band. So
There is ones you can get that do use the ham license. It's a little more powerful, but with the LoRa signals, you don't need a lot of power. So. Not really radio related, but this is a little project I started. All the blue parts are designed by me, and All the electronics are encased in here. It's a little drone I've been working on.
Can you show some of these on the screen so that we can see them on a remote meeting?
Oh, they're on the webcam view. They should be.
Sorry about that.
Yeah.
Forgot about the webcam.
I totally forgot, I'm so sorry.
Oh, yeah. I pointed it. Yeah.
Oh, did you have pointed it?
Yeah. Yeah.
And here's the Meshtastic nodes. That's the solar one. And these are the two handheld ones. And these two are just stuff you can download and print. This one is just this piece I designed.
I think you have to turn off the sharing because we're just seeing the presentation.
Try to hit on Joe Resnick's frame.
This is kind of neat. I made a few of these for my wife. She likes these. But the neat thing about these, it uses what's called vase mode. So where Andrew was talking about how it does a layer, this is actually one continuous spiral all the way around. So there's no actual layer. It just keeps spiraling up, and they're pretty neat. She puts little LEDs in them, and I don't know, we've got probably about 6 or 7 of these around the house, different shapes. Actually, I have a Christmas tree also. It's about that tall. That is an extruded snowflake, and it comes out and goes in, and it looks like a Christmas tree. But if you look at it like this way, it's a snowflake. But I would have to dig that out of my Christmas stuff, which is buried by Halloween stuff, seasonal stacks.
Gotta go in order.
And then there's little things like this is a little. When I was playing on just dialing in my printer, I like things like this with movable parts because you can tell your tolerances in that.
Is that one of the ones that prints like
Prints
that,
it-
or did you put it
It
together?
prints in one piece.
And that's what I
And it
love
just
those.
goes all over.
Those
It's
are
got a
so
fun little feel to it. My wife likes fidgeting with it at her desk. It's like a kitchen glue. And this is another one that I would use for testing, just because it does a little bit of up in the air, so testing. The bottom pieces, it starts with 4 different pieces and then merges them all together. And this is actually a flexible material here, so you can actually bend it and almost squeeze it, but there's an infill to it. And I probably got, she got a whole collection of these. I think I printed them in like 12 different colors for her. She didn't like frogs, but.
Sorry, I'm still seeing the presentation. I'm not seeing anything being shown through the camera.
You have to pull up the viewer screen.
Or go to Joe Resnick's frame and pin on it and expand it.
Or turn off sharing. You can just turn off sharing and then fix it for everybody.
This is a simple little phone stop,
No.
There we go.
which comes in handy. I don't use it too often, but when I work, sometimes I have to video, and I
Okay.
don't like use it on my laptop, and I just put my phone there and do the video through the phone. Works a little better with Teams that way. And
Now you got it.
here's what my son wanted to go as Iron Man for Halloween one year. So I printed him a little arc reactor for experimental Marvel. It's
Your
from
man's
the comic book Iron Man. He had the little thing on his chest.
Oh.
My son had the costume, and I'm like, oh, that's kind of boring. So I 3D printed this and put the LEDs in it. It's about 7 different pieces in here. I didn't design this. This is another one I downloaded. I did design the back piece though. This is another one where you were talking about the mechanical and the 3D printed. I forgot the term you used for it.
Oh yeah, mechatronics. Yeah.
Yeah, and this is more along that line. This is for I have a smoker at home, and I like charcoal, like the taste of charcoal. And all the people that have the Traegers and that, you can set them and forget it, and just put whatever temperature you want. So what this does, it actually has a blower motor on the inside, a servo in here, and it hooks up here to a Raspberry Pi, thermocoupler, and thermal probe into the meat. And it'll actually open and close, so that can actually shut your grill completely down, or open up and blow the air through to heat it up. And I can keep within probably about 3 degrees on charcoal, and that's not easy to do on charcoal. There's little vents, you're always playing with them, and it's kind of hard. And that's about it. Most of the 3D printing I do is for home repair stuff, so if I had to take apart the cupboards and like little things, like those little clips that when you put your shelves in your cabinets, those little clips that go in, they break, and it's like, where do you get them? You find somewhere to get them, you gotta buy 50 of them. I'll store on the printer, print 2 if you need. They break another 2, print another 2. You know, just little things
Yeah,
like
that's,
that.
that's a whole 3 minutes of printing.
Yeah.
Right, that's right.
So I could go to the hardware store, or I can just click the
Yeah.
button. and Wait.
One other little handy tool I have.
Well, that LED one, that's pretty cool.
You talk about downloading files.
Yeah.
If you download somebody else's file, is it easy to modify or is it kind of compiled?
It depends which format. Myself, when I post stuff on Thingiverse, I post the both the FreeCAD file and the STLs.
Okay.
So the STLs you could pull back into a program and import them, but it's kind of wonky and you don't have as fine control over like if you wanted to make a small change. So I always when I upload my stuff, I put both the base CAD file and the STL. Some people just do just the STL. So then it's a little bit harder because you have to like back import it into your program, convert it to a solid, and then kind of do some other stuff. And it's not as easy. So yeah, it's up to whoever uploads it really.
And this came from a kind of necessity kind of thing. I dropped a container that had LEDs, 4 different colored LEDs. So, yeah, I could have got out my breadboard and, you know, did that, but I made a little LED tester, put a CR232 battery in there, and just pop it in there. 30. See what your LED, or you could use it for testing the LED to see if it's any good. You know, and then from that, I ended up making a bunch of little tree ones. And for my wife's decorations for Christmas, so I put a little one in there, and the battery lasts a few days, you know, week or so. And that's it. The only other thing I wanted to mention was for software. You mentioned the FreeCAD. Autodesk also makes a program called Fusion 360. The neat thing about Fusion 360 is as you design something, you go all through the design, you get to the end and you realize, wow, this piece is the wrong size. Well, a lot of things like that, you got to restart your whole project, start from there. Well, Fusion 360, you have a timeline. You can scroll back to when you did that piece. And then you can change the dimensions of that piece and then scroll forward and it'll fuse that into the rest of your project, which is kind of nice because I'm sure that you guys are both, when you're designing something, get to the end, you're like, oops, yeah, and then you gotta start over or whatever. But Fusion has a nice feature for that.
Yeah, you could kind of do that in FreeCAD if you do all your dimensioning based on calculations.
Gotcha.
So if you say, I want to make this, you know, 3 off of
Right.
this surface right here, and then calculate it based on the previous dimension and chain them all together, you could do that. But yeah, if
Yeah,
you don't do
Fusion
that,
is natively,
yeah,
just
if
like
you
that
don't
kind
do
of
that,
timeline across the bottom.
yeah.
There's a
And
lot of CAD places that also uses Fusion for a lot of like different molds, a lot of different CAD molds.
So you can even do CMM with it. You control
Yeah.
mill with it. You
Oh, yeah,
control
I have,
machinery.
It's
Yeah.
been a while since I've used it, but.
Right, right. Yeah, it's a very powerful tool. But the maker version, though, you don't get as many of the
Right.
features. You can control a mill through it, but you're not gonna get all the.
Yeah, you're not
Heavy
gonna
duty.
get all those pixels.
Right, right.
Tom, aside from that Fusion 360, what kind of software do you use as well?
Fusion 360 is mostly what I use for designing. But then the slicing program, like he was showing Cura on there, I use something that's just called a slicer. But I'm switching over to a new software called Orca. That's what I use. And also there's new software for 3D printers that are called Clipper. And if you put Clipper on your 3D printer, it pretty much turns your printer into a dumb device. And then you have to use something like you talk to Octoprint to do all the heavy lifting. But the nice thing about that is when you get rid of all the processing on the printer can print faster, it can do more because you're controlling it with another device. So you need a Raspberry Pi or something that hooked to the printer exclusively to print. Whereas like right now, you could copy a file right to the printer, print without any of that. But the Clipper is kind of the next generation out there. A lot of the newer printers are switching over to that.
Yeah, so, yeah, thanks.
Yep.
I think that does it for about time, so I'll just leave one last thing. Something that I kind of want to do this year. I know we have a lot of experts in here on a lot of different topics. So if anyone has anything that they're very passionate about, mobile installation, grounding or bonding, digital voice, Meshtastic, UHF, VHF, super high frequency, anything like that, if you are very passionate about and kind of want to share that expertise with the club, we'll welcome you to present. So kind of want to, share the knowledge that we all have. I know talking with a lot of you, like there's probably thousands of years of experience in this room that we if we all share it with each other and we all get that experience and we all learn. So that's it for me. So thanks, and I'll turn it back over now.